This is part 11 in a series of videos in which I'm repairing and restoring this HP9862A plotter. So far I've got the unit basically functional and carried out some repairs, replaced some parts, and before we get on to the next stage in repairing this, I've just got a few quick announcements I want to make for some products that are now available on my own website. If you're not interested, then jump through to this point in the video. But for those of you that are interested, just a few quick announcements. For some time now I've been supplying bare boards to assemble these. It is of course the Mark 14 computer, and these have been quite popular, and one of the main issues I've had in supplying these is the type of switch that's used, and the one I selected was to allow the design to look very similar to the original design. Bear in mind this is a reproduction of the very first version, and one of the problems is that the switches are fairly easy to get, but they're fairly expensive, and some people have complained and said it would be better with a cheaper type of switch. The only problem is, of course, it wouldn't look quite the same. So what I've done is updated this board, and to try and give everyone the best of both worlds, the new board is identical at the top, so it's still a true to form reproduction. All the tracks, the layout, everything is exactly the same. It still takes the same switch types that the first board that I released takes. The only difference is this board also supports this type of switch. These are the A14 type switches that are much cheaper. So you can put either type of switch in, it just depends on which ones you prefer. And of course with the A14s you can get caps and make your own inserts if you want to, so it clips onto the top of the switch. Or of course you can still use the frame that I supply to make the appearance the same as the original. Depends on exactly what you want to do, but this should make it much more versatile and easier for people to assemble. Okay, the other update is finally the books have arrived, so anyone that's been waiting for these, they are now available. Apologies to anyone that ordered a while ago and has been waiting. All the orders have now been shipped out, and these are available on Amazon or most main bookstores. This is the book I've been talking about in previous videos, and details the design and development of this, which is a magnetic core memory system. And as promised, I'm making bare boards available as a kit. So this is what you get in the kit. There is the main logic board, so it's quite a dense board, there's quite a few components on there. And also there is the array board, the cover for the array, that's just to make sure you don't damage the array once you've finished assembling it, a full set of cores, some non-metallic fixings, using non-metallic to make sure they don't interfere with the magnetic properties of the array, and some suitable solderable wire. There's actually about twice as much as you'd need, but it's better to have too much than run out halfway through. And of course there will be detailed instructions as well that come with the kit, so it goes through all the assembly, the layout, and how to test it. So that's now available. It will be on my website shortly. It's already on eBay, and so they're the updates, and for anyone that's interested, as I say, these are now available. So back onto the plotter and we'll get on with that project. And so far I've got it up to the point where it is fundamentally repaired. It seems to be working, and I've still got to source a few replacement knobs for it, but it's pretty much finished now. It just needs a few finishing touches, and it's ready to connect to a calculator. To enable me to use this, I need obviously some pens for it. Now the pen holder, the actual carriage part of the pen holder was missing, so I've 3D printed some of those, and they're working quite nicely. And I also needed pen holders you can still buy pens for this, and I have made this in such a way that it will match the original pens, but unfortunately they're very rare and very expensive. So in the previous video I showed one of these. This is an adapter I've made to allow me to use ballpoint pen inserts, but of course you can make these to suit whatever you want. So I've got another one fitted that allows me to use ordinary felt tip pens, and they're about 1,000 times cheaper literally than the original pens, and they work just as well once you've got the adapter. So just a quick demonstration. I've still got the pick controller attached that I made up, so we'll just quickly run this, and I'll show you it running on a felt tip pen. So as you can see, it's working fine, getting very nice clear images. Now the next step is to connect it to a calculator, but this is where I run into the main problem with this, and that I don't have the interface cable. I also don't have the ROM cartridge for the calculator. Now you can kind of use this without the ROM cartridge fitted, but it doesn't really do that much. It's much harder to use. You have to write very explicit programs. So I've decided to do two small offshoot projects from this one. The first one is to produce reproduction interface cards for this. So that's the card that sits on the end of the cable that plugs into the plotter. So it's essentially the interface between the plotter and the calculator. Not to be confused with the interface within the plotter itself. There is an interface card in this, but that's a different card. It's for a different kind of part of the sequence. You actually need a small plug-in card to connect the plotter to the calculator. It just performs a few simple interface tasks. Now the problem I've encountered in trying to do this is that I don't have one of those cartridges as a sample, and the only images I can find online for it do not match the schematic that's in the service manual. I've been going through all the information I can collate and trying to figure out exactly what's going on, but I'm left with a couple of issues that I'd like to ask for some assistance with if you've got one of the interface cards. So we'll go over to the PC and have a look, and I'll show you the information that I need in order to complete the interface. The second project will be a generic ROM card for the 9830A calculator, and that will allow images from all the different types of ROM module that are available to be put into a more modern EEPROM. But I'll come onto that project in a later video. For this one, we'll just go and have a look at the interface card, and I'll show you how far I've got with it. Okay, so this is what I've done so far. I've been bringing together and collating all the information I can find on the interface card, and trying to figure out exactly how it's all laid out. Now, it's not as straightforward as it may seem. It would be nice if there was an accurate schematic, but while there is a schematic in the service manual, it does not match the images that I can find online. The schematic shows 12 ICs, but there are only 10 on the board. There is another schematic available, but that is quite close, but there are some discrepancies between what I can find in the images and some of the actual connections shown in that schematic. Also, some of the connections just don't make sense. The board wouldn't work with it wired up the way that the schematic shows. So what I've been doing, and this is where I'd like some assistance if possible from anyone that has one of these, is when I do these layouts, especially reproductions, I use an image of the original board. So for example, if I overlay the front side of the board, you can see this is how I get the original layout. I just need to make sure I get the scale correct, deskew the images and all that sort of thing. and if I have an original board it's easier, I can just measure it, but in this case I need to try and figure out key measurement points to try and get the size correct. And this is a 2-layer board, so there is this layer we can see here, which is the front layer. If I turn off the copper, you can see this is the image that I've been working from, and I can then use it to accurately lay down the tracks. The images I found online, there's quite a number, and these are some examples, and what I do is I mirror them where necessary so they match the essentially it's like I'm looking down almost like an X-ray through the board. And so this is the rear, but it's been flipped and mirrored, and then there is of course the front, which again I scale and try and get the overlay correct so that it properly overlays. But as you can see, the problem is that certain tracks aren't visible when they go under ICs. I don't have one of these, so I can't buzz it out. And the information I really need is what the interconnections are on this particular IC. So in particular pins 8, 9 and up to 14, I need to know what they're connected to, and also if possible the pins on this lower right chip as well. I think I've got all the rest, and I just need to know how these particular ICs are connected. It's further complicated by the designers, I presume, to try and make the layout as easy as possible, passed some tracks through non-used pins on some IC. So this connection here to this IC is not actually a connection to this IC, this pin to 7413, and this pin's not connected internally on the IC, but the designers of the board took advantage of that and led this trace through, and this is one of the traces that is showing differently on the schematic that I can find. And as I said, I need to know where the interconnections are, especially on these two devices. If you have that information, or you're able to do any testing for me, then please contact me. I'm getting fairly close now, and the idea is to make these available as bare boards to anyone that wants them. And then once I've done this, I'll be able to start work on the ROM card, which many people might find interesting if they have one of the HP calculators. So this is quite an interesting project, but as I say, it will be a lot easier if I can get some more information. Failing that, then the next step will be to assemble all this on a breadboard and carry out some experiments to see how it's interconnected. I believe I know how it's interconnected based on what it's supposed to do, but I'd just like confirmation of that before I go to the expense of having any boards made. So if you have any information on this, then please contact me.